In this video, I'll show how to use MyCurveFit.com to perform simple predictions. This is useful if you have some existing data and you want to make calculations, predictions, or extrapolations. Let's say you've just started working a job making $17.50 an hour, and you want to know how many hours of work it'll take to earn $100 and $1,000. We can use MyCurveFit.com to help determine the number of hours required using a linear prediction. I have opened MyCurveFit.com and have logged in with my free account. I'll plot hours on the x-axis and pay on the y-axis, so I'll go ahead and update those axes names. Let's create a chart for our example. I'll clear the data from my data table and enter the first point 0, 0. So for 0 hours worked, the pay rate is $0. Next, I'll enter our second point, 1, 17.5. So for 1 hour worked, the pay is $17.50. I'll scroll up to the fit method and select linear regression. So now our chart has been plotted with the 2 calibrator points. Let's make a prediction to determine how many hours will need to be worked to earn $100 and $1,000. I'll open the predict drop-down box, and because pay is on the y-axis, I'll enter the y value to predict the number of hours, or the x value. Entering 100 in the pay column, the hours column will automatically be populated with the number of hours to reach $100 in pay, a little over 5.7. Next, let's predict how many hours worked will return $1,000. Once we've entered $1,000 in the pay column, we can see that a little over 57 hours will need to be worked to earn $1,000. Looking at our chart, you can see it's also been updated to include our prediction points with blue triangles, 5.7 hours worked to earn $100 and 57 hours worked to earn $1,000. Now let's use a similar model to predict the pay rate given annual raises. So you receive a pay raise every 12 months. The pay rate for the first year is $17.50 an hour, the second year is $20, and the third year is $25. What might you expect the hourly rate to be after 5 years? Back in MyCurveFit.com, I'll clear out the predictions and the data, and I'm also going to update the x-axis title from hour to year. So now I'll enter my pay rate for each year. Year 1 was $17.50, year 2 is $20, and year 3 at $25. So our chart has now been updated to show the new linear regression model with our updated data points. Now let's say I'd like to predict how much we'll make per hour in year 5. In the prediction column, I'll need to use the swap option to be able to enter the year. So to predict the hourly wage for year 5, I'll enter a 5 into the year column. And again, the chart is updated to include our prediction point, and we can see that the pay rate we could expect is a little over $32 an hour. We've been assuming a linear relationship between the year and the pay rate, but what if the pay rate was instead exponential? We can update the fit method by using the drop-down box here and select a nonlinear equation, exponential. You can see this appears to model our data quite well, and looking at the goodness measures, the R squared is higher with the exponential fit when compared to the linear regression. With this model, looking back at our prediction, we could expect to make $55 an hour in year 5 of employment. So using MyCurveFit.com, we've been able to make some simple predictions using our existing data with both a linear regression and exponential model. If you have any questions about using MyCurveFit.com or how to create predictions using your data set, please email us at support@myassays.com.